Okay, so I wanted to just do one example of a different kind of linear interpolation, and I believe this is from exercise 5E. This is question 5. Okay, and really this is just sort of another way of thinking about linear interpolation. Okay, so linear interpolation. Okay, and I would encourage you as well to just go back to the first video if you're a bit rusty on this topic. So here's the question. Part A is not too bad. Part B is where we're going to focus. So we have some data about the number of pounds, and it's rounded to the nearest pound, which is a bit of a clue about something we're going to have to do. Use your calculator to work out the mean and standard deviation. Okay, so what we can do is we can pretty happily find the mean by doing sort of fx. Okay, so x would be 8 times 14, and so on, adding these all up and dividing by the frequency that is there. And if you do this, this should be 869 over what number? 85. Okay, and you should then get your estimated mean, which is 10.22. Sorry, I shouldn't say estimated mean. This is an exact, it's kind of an exact mean from the table, but the data itself was actually rounded. So it is an estimated mean of sorts. Using the M, S, M, S, M, and then square rooting this, which is standard deviation. I'm not going to go over that here. You can check the video for yourself. You'll get an answer of 1.35. Okay, so that's how you get the first 3 marks. So the next part says, how many students received an amount of money more than 1 standard deviation above the mean? So 1 standard deviation above the mean. Well, this is the mean, and this is the standard deviation. So if we add them together, so if we do the mean plus the standard deviation, okay, we just add these numbers together, okay, and we'll get 11.57. So the question's asking us really, how many people are above 11.57 here? And it's not as simple as just saying 20. Okay, because things here have been rounded to the nearest pound, right? So one thing we might want to do is we might want to start thinking, well, this is probably linear interpolation. So one of the things we could do is, first of all, we could convert these bounds to being more appropriate. But actually, yeah, okay, I mean, let's do that. So let's start with the 11 one. So for the 11 one, 11 really should be 10.5 to 11.5, shouldn't it? Okay, and the 12 one, because this is again to the nearest pound, the 12 one should be 11.5, okay, to 12.5. Okay, so if I'm talking about people who are above 11.5, sorry, 11.57, 11.57, it might help if I put a 0 in there. Clearly, I'm not actually talking about this group. I'm talking about something going on in the last part here, okay? And we can use linear interpolation for this. However, this is kind of a different question, because normally with linear interpolation, what we've seen so far, we were going from a number like halfway or a quarter, and we were ending up with an answer like this. But now we actually need to go the other way. And it may help to think about linear interpolation in a different way as is presented in the book. So there is an alternative method to doing linear interpolation which can be used to solve problems like this. So let's just look through a case here. So in some example here, use proportion to estimate. Here they were estimating some quartile. And they looked at values, and they were looking at the 52.5th value, okay? And they were looking at how far this was into a group that started out of 27. So how far was this value into the group that started with the value of 27? And look, this is the width of the group. This should look familiar to you. So we made a fraction about the proportion here that the frequency was into the group. And then here underneath, there was another fraction, okay? And this was about the thing being measured. So we do one fraction about the proportion of the frequency. That would be like over here. And then we do another fraction about the proportion of the other thing that we are measuring. And the idea is that the proportion that you are into the group should be the same for both. Don't worry if this is a little bit abstract. So what we're going to do is we're going to say, let's start with the 11.57 first. The 11.57, okay, is in this group. So I'm going to say 11.57, okay, minus 11.5. So how far is the piece of data? How far is the number of pounds into the group for pounds as a proportion? So let's redo that. So this should be 12.5, okay, minus 11.5. So this should seem quite familiar to you to how we did linear interpolation before. What this does is this says, you know, what proportion is 11.57? What proportion is this important value that I found into the group of frequency? Well, whatever proportion it's into the group of frequency, that proportion is the same as the number is, okay, into the number group. Sorry, sorry, that's the other way around. Sorry, this is the proportion for the pounds. This should be on the top. So whatever the proportion is into the group for the pounds should be the same as the proportion into the frequency. So what number is this into the group? Well, actually, that's what I don't know, and that's what I want to find out. So I'm going to give this a letter. So this is going to be S, because I'm trying to find how many people this describes, how many people are in the 11.57 position. Well, it's in this group here, okay? It's in this group here. How far in the group is it? Well, 14, I'll say, is 22, plus 28 is 50, plus 15. So before here, if you add this up, okay, there are 65 people. So how far is my mystery number in as a proportion? Well, whatever it is, it's minus 65 to get it to the start of the group. And as a proportion, well, what's the width of that group? It's from these 65 people and then on to 85 more. So I'm going to just write it as it's written in the solution bank. In the solution bank, it's written as this, but actually from the table, the way it's presented, it probably makes more sense to think of it like this straight away. So proportion into, what's this? This is proportion into the pounds. So the proportion that this piece of data is into the pound group is equal to the proportion, let's write proportion, shall we? The proportion into sort of the frequency. And if you set this equation up, okay, and I have set this equation up, it's not that I work something out on the left and it gives me the right, no, I have set this equation up. Well, we can start to simplify it. On the top, let's change color, shall we? How can we do that? Let's do orange. So on the top over here, 11.57 minus 11.5 is going to give me 0. I thought we changed color, never mind. It's going to give me 0.07, okay, as the numerator on the left-hand side. 12.5 minus 11.5, that's actually just 1, isn't it? is equal to, well, the same thing again over on the right. There's not much you can actually simplify. Okay? And if you get this S here, if you get this S on its own, what you should do is you should get a value of S equals 66.4. In fact, I might recommend against using S because it's a little bit unclear, isn't it? Okay. But what we're actually finding is we're finding this one here, the number in. So it's 11.4. And if you think about this, this makes sense. It goes up to 65 people at the start of this group. So it's sort of like 1.4 people in. Check the question though. How many received an amount of pocket money more? Well, this takes you to the 66.4th sort of position. And there are 85 in total. Okay, there are 85 in total. So how many people are above 66.4? Well, it's 85 minus 66.4. Okay, your answer for that one there is going to be 18.6. So there are 18.6 students who are above this magic point. And this one here, we can round it and we can say that this is 19 people. I think this is 19 students. Okay, I'm just going to write 19 students. So what's going on here? This is using an alternative sort of way of thinking about linear interpolation. This is generally more complicated, but it can be used to solve these problems. Okay, so you say the proportion that the number is in to one group is equal to the proportion that it's into the other, and you can set up these equations like this. It does take a little bit of practice, but my piece of advice to you would be: look, all of these numbers are about the pounds here at the top, okay? And there's kind of a pattern to it. And all of these numbers here, this is about frequency at the bottom. So you can kind of get into the swing of this. Each time as well, we have sort of the width of the group that we are looking at on the bottom, okay? What these key values are in the top left, and take away the start of the group as the other bit on the numerator. Okay, it's a little bit tricky, but I hope this video helps you with this and similar questions in the exercise, such as question 7, that you may wish to have a go at now.